Hello everyone. Today in this lecture we are going to see Murray machine. In Murray machine the output is also always associated with the state. In Murray machine, as we know that the output is associated with the state. So we'll see basic skeleton. Q0 0, Q1 1. That means Q0 is a state, A will be the output. Q1 will be a state, 1 will be the output. And if it takes A, that means how can we write? Q0 after taking A, it is going to Q1. Q0 after taking A, it go with the Q1. This is the transition with delta, that's state transition. And for output transition, how can we write? Q0 is a state. After taking A, it gives 1. That means Q0 is a state. After taking A, where it goes? Q1. But what is output associated with that? It's 1. So that in Murray machine, we always check the output, but output always associated with the state. Similar way, we'll see the Mealy machine, which we have seen in the last lecture. We know that Q0 will be a state and Q1 will be a state. In this problem statement, Q0, Q1, we write A1. That means Q0 is a state, it is going to Q1. What is output? 1. How can we write? Delta Q0 after taking A as the input, it goes to Q1 state. And output transition, Q0 is a state. After taking A, what is the output? Output is 1. If you see the difference between Mealy and Murray, what we come to know? It is the Q0 after taking A going to Q1, same, but the output associated with the state. In Murray machine, output associated with the state. In Mealy, the output associated with the transition. This is the major difference between Mealy and Murray. In Mealy, we have seen some examples in last lecture. So in today's lecture, we will try to learn Murray machine in detail with the example. So let's take an example question. Construct a Murray machine. Construct a Murray machine that output or that print 1 whenever the string AB occur, else print 0. So in given problem statement, please read carefully. Construct a Murray machine that output 1 whenever the string AB occur, else print 0. That means we'll write language first. What is the occurrence? AB occurrence. Whenever AB occur, it must print 1, else it print 0. This we have to show. This is 1. Fine. So try to draw the diagram. Q0 after taking A, it is going to Q1 state. We have to draw for minimum length first. Q1 going to Q2, it is taking B. As per the rule, whenever AB occur, we have to print 1. So state with 1, else state with 0. Now we'll see all the inputs. Q0, A covered. For B, we can go with self loop. For Q1, B is there. For A, I can go with self loop, I don't have any problem. For Q2, for A, if I go with A with Q1, so we'll see, if I go with A with Q1, AB1, AB1. So it's correct. Whenever you will give some input, try to run the string. In the string, we are looking for AB, that shows 1 output. AB, print 1. BAB, last is AB, will print 1. That's correct. For B, we can't go with a self loop. With self loop, it may be AB, self loop may contain BB, n number of B, and it is printing 1. So it's wrong. as per the problem statement. So self loop is not possible. For Q2, can we go to Q1? Q2 to Q1, it's not possible because a state will not take two different input and go to the same state. So check, is there any state remaining? Yes, that's Q0. So we'll come here for B. Now we'll run BAB will print 1, AB will print 1. Check BAB, B means BB. What is going to print? It must print 0. It must print 0 because else it should print 0. Then check, if it takes BA, it must print 0. BA, it must print 0. That means a number of BA, it always print 0. Now with this diagram, we can show that whenever AB is occur, we are going to print A. So let's take some example and we'll run whether our diagram is correct or not. Language BAB AB. Can we run this language and we'll see what is the output. For B, what is output associated with the state? 0. For this A, what is there? 0. For this B, there is 1. Whenever 1 comes, we have to check whether there is AB. Yes, there is AB. We are correct. Now the A will come. What is output? 0. B will come. What is output? 1. Whenever 1 comes, we have to check whether AB is there. Yes. For more simplicity, we'll take some more examples and learn. Language equal to BA BBA. BA BBA. That means at whenever AB occur, it must print 1, else it must print 0. For single B, it's always 0. Single B always 0. For BA, A prints 0. The B will print 1 and check whenever 1 comes, AB must be there. So it's correct. For Q2, whenever B will come, it will print 0 and after that it will take A as input, it will go to Q1. With Q1 there is 0. So with this we can say that whenever BA will occur, it will print 1, else it will print 0. We will have quick revision. What is the problem statement and how can we show that? Construct a Murray machine that print 1 whenever AB occurred. Very first, try to draw the states, satisfy the minimum length of the language and give the output of the state. Remaining, check every state with both the inputs. Every state with the both the inputs. Every state with the both the inputs. And you should aware that a state will take one input and it will go to the some different state. There must not be a possibility that a state will take both the input and it is going to same state. It will be in wrong condition. So Q2, we have checked both the conditions. Now after completing that, run the string carefully and try to check that wherever AB will occur, it must print 1. For this, we have seen the language BAB AB. We have run that whenever B comes 0, A comes 0, B comes 1. So whenever 1 comes, we will come and check whether there was AB. Yes. So for A, there is 0. For B, 1. So AB come, there is 1. So for second example, we have seen BABBA. Can we run the string? Yes. For B, it will print 0. For A, it will print 0. For B, it will print 1. Whenever 1 comes, we'll check whether AB is there. Yes. Then B comes, output is 0. We are here now. Then A comes, output is 0. Here, please keep in mind, always in Murray machine, as I told you that output is always associated with the state. So we can write here output with state. Output with state, and in Mealy, output with transition. This is the example of Murray machine which we just have seen. Thank you for the listening. Do subscribe on my channel. We'll see more examples in future. Thank you.